Hello again. Now we're on to section 1A, question 9 of linear algebra done right. So the question was to show that lambda times, in brackets, alpha plus beta equals lambda times alpha plus lambda times beta. So distributive property. And lambda, alpha, and beta are all complex numbers. Remember, the upside down A means for all, so that reads for all lambda, alpha, beta in the complex numbers. So to prove this, we're basically going to work on the left-hand side, bring it down to something, keep expanding it down until we get a very general, something that's very general but still equal to that left-hand side. Then we're going to do the same on the right-hand side, and they should equal each other at that stage, at the, say, the most expanded stage. So we're going to let each complex number equal the real, it's like a real valued expression for it. So A and B are real numbers. I is the imaginary number. You should know that. And let's get started. So the left-hand side is lambda times alpha plus beta. That's lambda e plus fi, alpha and beta, right? So we can use the definition of addition and see. We can't straight prove it by distributing because that's not defined in the complex numbers yet. That's what we're proving. So we use addition in complex numbers, and we add the real coefficients and the complex coefficients. We get a plus c, b plus di. Now we have two complex numbers multiplied. So we use the definition of multiplication defined in the complex numbers, and that would be the first, so real times real minus imaginary times imaginary plus, and then in brackets, so that's the second part, the imaginary, the first one, so imaginary times real, just f times a plus c, and then real times imaginary, e times b plus d. Okay, you could quite literally just distribute it out and simplify it down, but if you do that enough times like I have, you'll pretty much remember how it works. You'll be able to do it in one line. So we distribute out because we can do this now because these, remember, these are all real coefficients. So real numbers, you have the distributive property defined. So you can go EA plus EC minus FB minus FD, just do that for all of them. Okay, and then this, now let's see if we can turn this now see if we can turn the right-hand side into this as well, which means it equals the left-hand side. And if we've done that, we've proven this. So right-hand side, we have lambda times alpha plus lambda times alpha. We use the definition of multiplication in the complex numbers twice here, one on there on the first term, second one on the second term. So that's the same property that we did here from this step to this step. Once you do that, you get two complex numbers, which you can add. So we add them and rearrange the values, the terms, and until it becomes the same as what the left-hand side was. And then you could say it equals the left-hand side as required, and that proves it. So that's the proof of question 9. I will see you in the next one.